Okay, this is Dr. Williamson solving problem 1636 for you guys. And it says, without consulting table 16.3, give the units of the rate constants for reactions with the following overall orders. First order, second order, third order, 5/2 order. I'm going to show you guys the process for solving it rather than memorizing, right? Now, for first order, you would just write R equals K A to the 1 power. And you have to remember that R always has units of, we could put, sometimes that's used for saying has units of molarity per second. And this always has units of, so they put equals in little brackets. That means has units of molarity. So we could go molarity per second equals K molarity, no numbers. And if we solve for K, we're going to get molarity per second times 1 over molarity. When we divide both sides by this molarity, molarity cancels, and we'd be left with 1 over seconds, or we would say K has units of seconds to the -1 when it's a first order reaction. Okay, that's something most people generally memorize. For first order overall, it's seconds to the -1, but okay. So let me erase this stuff. Okay. Now, let me do the next one where it says here, second order. Oops, I don't want a highlighter. Pen. When it says second order, we can get second order one of two ways because it says overall second order. We could write this B, and that would be second order because we would get molarity times molarity. We'd get second order that way. Or we could get second order by writing A second order because it says overall order. I'm going to go this way. Now remember, rate is always molarity per second and concentration is always molarity. So we're going to have molarity per second equals K. And this is always molarity, but this time it's squared. Now then we solve for K. And we're going to have molarity per second times 1 over molarity squared. One of these molarities cancels with one of those, and we'll end up with K has units of molarity, the -1 seconds to the -1 when it is second order overall. I'm showing you how to figure it out so they can throw any weird order at you and it doesn't matter. And you don't have to memorize. Right? If you figure it out, then you only have to remember one thing, how to figure it out, instead of a bunch of different things. Third order, we would just put a 3 here, right? We're going to have molarity per second equals K. And we're going to have molarity cubed. K will be molarity per second times 1 over molarity cubed. This will cancel and make that molarity squared. We'll end up with molarity -2 seconds -1. Right? I could have had third order by having R equals K A B squared. I would have got the same result. Or I could have even had A, B, C. Still would have got the same units for K. All right. Still would have got the math, the units math would have come out the same. All right. You can do it. You just got to learn one thing. The more you understand, if you understand one thing, there's 10 times less you have to memorize. It's like a 10-to-1 payoff. I prefer that. Okay. So here it says 5/2 order. That's 5/2 order. What do? You're going to have molarity per second equals K molarity to the 5/2. K will be molarity per second times 1 over molarity to the 5/2, right? And this is molarity to the 2/2, right? And that's going to leave me one, if I do it right, if I'm not having a brain fart, 1 over seconds times 1 over molarity to the 3/2. Sure hope I'm doing my fractions right. And that's going to be equal to molarity to the -3/2 seconds -1. And that's how you do that. Okay, guys. I'll try and do more for you later, but that's how you do problem 1636.